Hi there, grade 12s. In this video on my series of videos on organic reactions, I'd like to cover the topic substitution reactions, which implies that some atoms would be replaced in the chain during the reaction. So my first substitution reaction that we will be looking at is the reaction called where an alkane reacts with an halogen to form a haloalkane and the hydrogen halide. This reaction is called halogenation. Now, we had an halogenation reaction when an alkene was added to the halogen. So just to refresh your mind, during an addition reaction, we also had halogenation, where an alkene reacts with an halogen to form an haloalkane. I'm only refreshing your mind now. So, for example, we had ethene. Now, this reaction is spontaneous and it takes place within seconds. If you add bromine to this, it made 1,2-dibromoethane, because the double bond broke and your bromine, both the bromine atoms could add to the molecule to make 1,2-dibromoethane. Now, this reaction I've discussed in a previous video. The thing is that this reaction is a fast reaction. It happens instantaneously, that the brown color disappears, so to form a colorless solution, because the the 1,2-dibromoethane in the solution would be colorless, where you start off with the brown, obviously yellowish brown mixture of bromine water in the presence of the alkene. Now, in this reaction, where the alkane reacts with an haloalkane to replace some hydrogen atom, this needs, the condition here is that you need UV light. Ultraviolet light is necessary, and the sun contains ultraviolet light. So my example, we are going to do two examples. The first example we're going to do is we're going to take methane and we're going to react chlorine to that, and it will make chloromethane. And because the hydrogen breaks off the alkane, the hydrogen chloride will be forming there. In terms of structural formula, methane has 4 hydrogens joined to the carbon. This is also called tetrahydride. Methane is carbon tetrahydride. Sorry for my tongue twister there. And chlorine. Now, the bond in the presence of UV light will break there, and one of the hydrogens will break off to make chloromethane. And the hydrogen joins onto the chlorine that remains from the atom. So this is the reaction in terms of structural formula, the reaction equation. It's not too difficult to write it in terms of condensed molecular formulas. CH4 plus Cl2 goes to CH3Cl and HCl. The next reaction, now this reaction is much slower than the addition reaction because the double bond in the addition reaction is much easier to break than the single bonds in the alkanes. My next example will be ethane, just to compare it to the ethene we had in the addition reaction. Ethane has single bonds and each carbon has 4 bonds to 4 separate atoms, and I'll use bromine because bromine is unlike chlorine. Chlorine solution, chlorine water, is a colorless mixture, where bromine water is a brownish mixture. This brown color will disappear over time if the mixture is left under UV light, and one of the hydrogens will break from the alkane to make bromoethane. In this case, you can say 1 bromoethane, and hydrogen will join up to the remaining bromine atom. So this is our first type of substitution reaction. Obviously we must be able to write this equation in terms of condensed structural formula. CH3CH3 plus bromine, Br2, will give you CH3CH2Br plus HBr. Right. I'll discuss the next one in the next video. Thank you for watching.